All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our neural networks module. Let's have a look at what we went over tonight. Now, last night, if you recall, we started going over the actual introduction of the hidden layers, and tonight we're going to pick up where we left off. So this is a hidden layer that has four nodes. As you can see here, we have our input layer, we have a hidden layer with four nodes, and then we have an output layer. I didn't connect all of the nodes, but just imagine that every one of the nodes in this hidden layer is connected to the inputs here, and they're connected by weights. Well, they're connected by edges, and the edges have weights. So this node here will have three connections to each of the inputs, and each one of those connections will have a weight. And that goes for this one, and that goes for this one, and that goes for this one. So every one of these nodes will have its own connections to each of the inputs here. So every one of them will have three connections or three edges with three weights. And then in return, all of the nodes in this hidden layer here will be connected to the output. So there's that. And we can choose how many nodes or units go into the hidden layer, and we can have multiple hidden layers as well. So now each of the inputs isn't directly connected to the output. Each of the inputs is connected to the hidden layer, and then all of the nodes in the hidden layer, those are connected to the output. And so this is just another step that we could take towards calculating more complex functions. Each of the hidden units will calculate its output value, otherwise known as its activation, based on the linear combination of all the units. And once we have values for all of the nodes in the hidden layer, we do the same thing again. Calculate the output for the actual output neuron based on multiplying each of the values for the hidden layer units by their weights as well. And so, in effect, the way this works is we start with inputs. They get multiplied by weights in order to calculate the values for the hidden layer nodes. And then those get multiplied by weights in order to figure out what the ultimate output is going to be. The advantage of layering things like this is it gives us an ability to model more complex functions. Instead of just having a single decision boundary, a single line, dividing our data sets from one another, each of the hidden nodes can learn a different decision boundary, and we can combine those decision boundaries to figure out what the ultimate output is going to be. And as we begin to imagine more complex situations, we could imagine each of the hidden layer nodes learning some useful property or learning some useful feature of all of the inputs, and us somehow learning how to combine those features together in order to get the output that we actually want. Now, the natural question would be, how do we train a neural network that has hidden layers inside of it? And this turns out to be an initially tricky question because the input data that we're given is values for all the inputs, and we're given what the value of the output should be, what the category is, for example, but the input data doesn't tell us what the values for the hidden layer nodes should be. So we don't know how far off the hidden layer nodes actually are because we are only given data for the inputs and the output. The reason that it's called the hidden layer is because the data that is made available to us doesn't tell us what the values for the hidden layer node should actually be. And so the strategy that people came up with was to say that if we know what the error or the loss is for the output node, well then based on what the weights are, we can calculate an estimate for how much the error for each layer inside of the hidden layer nodes weight. In effect, saying that based on the error from the output, we can back propagate the error and figure out an estimate for what the error is for each of the hidden layer nodes. And the idea for this algorithm is known as back propagation. And you can see here we have an example of, or a definition of back propagation is an algorithm for training neural networks with hidden layers. Now I'm going to leave it there for the night. We did take a lot more notes and we did dive a lot deeper, but I'm not going to dive any deeper tonight. But we will pick it up tomorrow. And of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.